subject for today's video is going to be naming molecular or covalent compounds. So this is all about nomenclature. It's a continuation of our nomenclature lecture. Now, again, if we want to identify a molecular or covalent compound, we know it will be that because we'll see a combination of a nonmetal and another nonmetal. In other words, these are elements found toward the right-hand side of the periodic table. Now, let's start with a few that you're probably familiar with to see if we can actually develop some sort of a protocol or routine for doing this. CO2, I think all of us know how to name this one. We know this is called carbon dioxide. Now, if we load down to the next one here, that's carbon monoxide. I think most of us are familiar with that one as well. And then this one we may not be familiar with, but we can name it in a similar sort of way. We'll call this Dinitrogen Pentoxide. All right, so using these examples, let's see if we can come up with the scheme that we can use to actually name any kind of molecular or covalent compound. So here's the scheme. What we see by looking at our examples here is that we start with a prefix plus the element name, but never mono for the first element. Okay, so if we go back and look at this, this is not called monocarbon dioxide, it's just called carbon dioxide. So if we have only one atom of the first element, we drop the mono and just use the element name. All right, we follow that with the element name of the first element. Then we use a second prefix to denote the number of atoms of the second element that we need. And then we use the element name root. All right, so in our case over here, instead of calling this carbon dioxygen oxide, we call it dioxide. All right, so it's the element root plus the IDE suffix. Okay, so these will always be named with an IDE at the end. All right, so again, the prefixes are going to tell us respectively how many of each particular atom we need in the formula. So here are the prefixes. Mono meaning a single one, di meaning 2, tri meaning 3, tetra meaning 4, penta meaning 5, hexa meaning 6, hepta meaning 7, octa is 8, nona is 9, and deca is 10. All right, so with this in mind, let's practice with a few more of these. So we'll start by going from formula to name, and then we'll do a couple where we go from name back to formula, just to be sure that we can do this in both directions. Again, following our protocol here. All right, so the first one, SF6. There's a single sulfur here, so we don't call this monosulfur, we just call it sulfur on the first element. And then we have a fluorine here. So we use the root of the fluorine, it becomes fluoride, but now we have 6 of these in front, so we have to use our prefix. So our prefix for 6 is, go back and look, hexa. Okay, so this would be hexa. Watch what happens here. Fluoride. All right, so again, this follows our protocol. Now, let's do this next one. So I've got chlorine and oxygen here. Now I've got 2 chlorines in front. So now I actually have to apply a prefix to the first element. So I'm going to call this dichlorine. And then take a look at what we've got here. We have 7 oxygens. Okay, so our prefix for 7 is hepta. So we're going to call this a dichlorine hepta oxide. Now I want to show you something here. In many cases, we end up with a situation where we have 2 vowels coming together, one at the end of the prefix and then one at the beginning of the second element name. And when that happens, what we usually do is we eliminate that first vowel, the one that's associated with the prefix. So we actually shorten this to dichlorine pentoxide. So that's the appropriate way to do this. Again, if you have two vowels that bump into each other, we normally end up getting rid of that first vowel. All right, so this would be dichlorine pentoxide. All right, finally, this last one. So we have phosphorus and oxygen. Ooh, we have 4 phosphoruses, so we call this a tetraphosphorus. And it looks like an oxide, but how many do we have? We have 6. All right, 6 means hexa. Now, do we say hexa oxide? No, we don't. We drop the A at the back of hexa, and we just leave the O for oxide. Again, get rid of the 2 vowels, leave 1 vowel. So this becomes tetraphosphorus hex oxide. All right? So now, let's see if we can go in the other direction. We also need to be able to go from names back to formulas. And this is actually quite easy because, again, not only do we know from the name what elements are involved, but the prefixes tell us how many of each element are involved. So we don't have to worry about, for example, charge balancing like we do in the case of ionic compounds. So for phosphorus pentachloride, I know I've got phosphorus and I know I've got chlorine. Now, since there's no prefix in front of phosphorus, we know that is a P1. So I'll just leave it as a P there. Pentachloride means that I'm going to have 5 chlorines. So that would be PCl5. And finally, let's take a look at the last example here. Dinitrogen monoxide. Okay, so I know I've got nitrogen and oxygen involved in the compound. How many of each? Now, dinitrogen tells me I've got 2 nitrogens. And then the mono in front of the oxygen tells me that I have only 1 oxygen. Now keep in mind, you've seen here that we do occasionally use mono, but we only use mono when it's on the second element, the second part of the compound. For example, we did that with carbon dioxide, carbon monoxide. There's the mono in front. So we actually have to specify that when the mono is in front of the specific second element there. All right, so we're going to practice a little bit more with this in class when we see you, and that will take care of it for today.